Hey, we're here. We're live.
Here. Do we have anybody?
We're not square. We're...
What?
I don't know.
Like...
But we're also
like
not
the
quite
50s
queer.
square?
I don't know.
Katie's here.
Kind of. Hey! Hello!
Where are you going?
We're
here. We're not
queer,
quite queer. Oh.
Like, you know that whole saying is
yeah, we're here. We're queer.
Anyway, today's Poe's second birthday. Happy second birthday, Poe. Oh, Jackie has a birthday coming up in less than a month. He'll be 7.
Wow.
So, Poe got some new toys. That's great. Jack, I saw on your Insta that you were like the caffeine bear at your Pride March or whatever.
Here's what?
It was like a caffeine a lot. He had little bear ears and like a shirt, like a Care Bear, caffeine a lot, Care Bear stare. I don't know. It was great. It was cute.
I like that.
Oh, a few more toys are on the way. Gotta love that.
Nice. Cool.
Well, looks like pretty much the gang's all here, and that's awesome. You know, but welcome to any lurkers. Not that that's a bad thing. Anybody checking out but not hopping in chat, that's totally cool. We're gonna get the show started now.
Yeah, sure.
Okay.
You're in charge. I'm just here.
I know I'm hosting today. Oh boy.
I just get to sit here all day. I don't do anything. You get to talk.
Sitting in this image with these shorts.
You don't like how your shirt's what?
It's like giving me real big hips. Alright, it's fine, whatever. Yeah, we're still intercontinental! Welcome, Federico!
Federico is here.
I won't do my typical Liz Italian, because I'm pretty sure it would be offensive to you, and I apologize on behalf of Americans that do Italian accents.
Yeah. Brandon's on assignment. On his way to an assignment right now.
Yeah, but yeah.
Possibly.
I don't know. Who knows if he'll get there. But he's going to good old state of Texas.
Apparently there's plane issues.
Yeah, there's always plane issues.
Well, there's nothing wrong with the plane. It's just that everything's being rescheduled.
And all that good stuff. So, all right. Welcome, everyone, to Cosmos with Cosmos. I'm Liz.
I'm Mike.
And today we're talking the James Webb Space Telescope first images. It's
first
here.
Pictures.
It's arrived. It's working. It's great. It's beautiful. It's majestic. It's awe-inspiring. And we're going to get into...
And every other adjective that you want to include.
We're going to get into those pictures. For those listening on the audio version of the podcast, you're not going to see shit. But you can go look up those pictures online because they're everywhere. Or you can just then hop over and watch the YouTube video.
Yeah, that's probably the best thing to do. For this episode, it probably is the best thing to just forego the audio... Jump onto the...
Well, you know what, but the pictures coming through here probably won't look as good as they would just on your monitor, but we'll see. Anyway.
Well, yeah, but still.
Yeah.
But
yeah.
still. This is going to be a visual episode.
Yeah, it'll be more visual than our usuals episodes. But anyway, of course, being that this is Cosmos with Cosmos, that we never have Cosmos, what are you drinking, Mike?
I just realized... None of us has given names.
I thought about it, but I didn't say what it was. So, quickly.
Improv
right. Your name of your drink. Are we drinking the same thing?
We're drinking the same thing.
Okay, then let's do this. We are both drinking the Enlightenment of the Universe.
Oh, shit. That's good.
You like that?
That's good, yeah.
And I'll let you say what's in the drink.
Okay, so the base is rum. It is white rum and orange juice. And then on top of that, because we live in the state of Utah, and Utah does not have Sunday alcohol sales, and we realized we did not have any coconut rum, I had to make coconut rum. So I went and got some coconut extract and added that to the rum. And you pour that on top lightly so that it sits, and then you pour cranberry juice. And
gently.
Well, you do.
Pouring.
The cranberry juice does tend to sit on top, but you can use a straw to actually push it down, and it infuses the coconut rum into the orange juice, and gives it sort of a nebulosity look.
Which is what we're going for. Cool. So we're going to be drinking those in honor of James Webb and the beautiful images that have come out.
In particular, one when the Carina Nebula.
Yes. But first, of course, follow us on all the things
All
at
the
Drinking
things.
Cosmos on Twitter, Cosmos with Cosmos, everywhere else. Follow us on Spotify, Google Podcasts, Apple Podcasts, YouTube, wherever you get your medias that you like to consume into your face and eyeballs. And of course, check out some links in the description of all our video and episodes. Check out Ron Proctor's YouTube page where he does some cool shit. And of course, buy some fantastic art by the talented Katie Davison, Wildixia, Wildixia on Etsy. Beautiful, cool artwork she does. And of course, check out episodes of The Shot on our YouTube channel and on our podcast platforms that come out every other Wednesday. Just little bite-sized, shot-sized morsels
Nuggets.
of nuggety science.
Astronomy stories.
Yeah.
Yeah, Jack.
Oh God, coconut water to the rum. Ugh.
We have a story, Jack. If you ever want to talk to us about it.
I think we told the story about the
really,
lady drinking
yeah.
coconut
Oh
water,
my gosh.
Of course, we have some drinking rules because this is a fun educational drinking video.
3 of them. See, I'm doing
Puppy
it right.
barks, any dog barking, any Star Wars references, and any Lord of the Rings references. Take a drink. Speaking of drinks, Jack has he's channeling my mom with a little iced Earl Grey.
Ooh.
Earl Grey, cold.
Yeah, it's too hot.
I know. You might hear our fan going in the background because it was just too hot not to have any kind of air circulation.
Yeah, we're under an excessive heat warning here, and so we had to have some sort of air or we'd melt.
Mm-hmm. But anyway, let's go to where it's cold. Space! James,
Very cold, at least with James Webb.
James Webb Space Telescope.
Part of it, anyway.
In case, I don't know, you're not listening to the news or you don't know anything about it, just a little recap. JWST, or I think I'll call it Webb as well. We were watching another show where he was just like, I'm just going to call it Webb, because it is easier to just to say Webb, and apparently #GoWebb.
And everybody knows about it now.
Yeah.
So,
it
they
is
should.
A million miles away, hanging out at L2, Lagrange Point 2, where it can kind of get away from shit and just do
Chill.
some science.
Yeah, do some real cool shit.
Real cool shit. It's got amazing image and science capabilities. It can analyze the spectrum of everything, basically, that it looks at. And it isn't like Hubble, where Hubble studies the universe in visible light. James Webb studies in the infrared. And so there are 2 primary cameras that they've been using.
Near cam and
the near cam, which is near infrared, so longer wavelengths in the infrared, and then the MIRI, which is the mid infrared, so shorter. And so what really...
You got that backwards, by the way. So the near infrared is actually...
What, you think I know anything about science?
So near infrared actually has shorter wavelengths because it goes... the next step is actually red.
Okay.
And then you have mid, and then you have the far infrared, which is a longer wavelength.
Longer, so it can see farther. But really what the importance of the infrared versus visual is it can see through shit. Like clouds of gas and dust that say Hubble can't see through, James Webb can. So it just has like better eyes, basically, and sees the universe slightly differently than Hubble does. And of course, it has better resolution. It's bigger and.
Oh my gosh, the resolution is amazing. It's amazing. Liz and I, we watched the news conference. We watched the reveal, and we had tears. It was.
Before they even showed images, I was like, why am I crying already? They haven't even done anything, and I'm crying.
I mean, my boss doesn't listen to this podcast, but yeah, I mean, I watched it. There was no way I was gonna miss it.
Yeah, I mean, I was working and watching.
Yeah, in fact, I told Greg, I was like, look, I'm watching the James Webb stuff.
It's important to what you do. My mom asked, so is Webb bringing the colors? Yes, I mean, well, they will post-process the images, and they will add in the colors to be able to visualize kind of different things.
The really, really cool thing is that, so infrared is something that our eyes cannot see. And so we have to add color to it.
Mm-hmm.
Excuse me. And so there is art to these pictures. There are artists that are adding color to it so we can visually see it.
And also to highlight, and for scientific reasons as well. But let's get into...
All right,
let's get into
pick
some
one.
of the
Pick
shit.
one. Whichever one you want first.
Here's what we're going to do. We're going to do
There
our
are
best
5
kind of
pictures.
displaying the images here. So let's go to our the universe. We're out in space right now.
We're out in space.
Right, we're hanging out. We're looking at. We're just looking at space like Webb is.
So as you can see, what we have here, James Webb is.
And what we're actually going to start with is not an image that was actually released as part of the first images. It was released the next day or a couple days ago, and it's of something that's familiar in our own neck of the woods, and that is good old Jupiter. Jupiter. And so it took this image of Jupiter in, of course, the infrared.
Yeah, this is a near cam.
This is with the near cam, and so the brighter areas or the hotter areas, the warmer.
But see, the thing with like the red spot is it also has to do with how they're processing it.
Oh, okay.
So I'm not gonna equate warmer because the poles will not be as warm as they're showing right now.
But this just shows that like James Webb is not going to just look at like galaxies and stuff. It's also going to be used for science within our own solar system and looking at like even Uranus and Neptune, and we can
Kuiper Belt objects,
we can glean
comets.
more insights about them and composition and everything. In this image, though, what's really cool is you can see one of its moons, Europa. There's a couple in here. But Europa is the most obvious one. They've kind of they've
eclipsed it.
They've eclipsed it a bit. But you can see next to the great red spot on Jupiter, there's this also this like dark spot, and that's the shadow of Europa.
Oh shit!
Which is
really
really cool.
Oh wow! Okay,
and in another
cool.
image of it, you can actually see the rings.
Now that is the coolest thing because
which is really cool. You don't usually see Jupiter's rings. People don't realize
not
Jupiter
from
has
this angle.
rings.
Not from this angle. So the first time that we saw the rings, I believe, was with Voyager. Voyager flew past, and they turned it around to give one more last look
and at
like,
Jupiter,
and they're like, "Wait a minute, what? There's
that?
rings." And they're really dusty rings, and and so they basically have to be backlit a little bit to actually see them in visible light, and that's how Voyager saw it. But remember, James Webb not looking at it in visible light, looking at it in infrared.
Yeah. Back to just like Jupiter, I actually really love this image, and I kind of want
picture.
it as like a print, like an art print, basically.
Even
though it's not like the most majestic thing or like high quality thing.
Well, for one thing, it's
just really cool looking.
It's not what we're used to.
Yeah.
With Jupiter.
Like Juno, you have just these breathtaking,
beautiful
all the
works of art. But this is a work of art in its own
atmosphere.
way.
Yeah.
And,
it gives me like a retro, like vintage vibe. Is what it gives me. I think that's why.
You know what's going to end up happening is you and I are going to get prints of every.
We're just going to have like our walls.
Picture.
It's just going to be space pictures everywhere. I mean, I don't see a problem with that.
No.
All right. Let's move on to something else that it's studying, which is also related to planets, but that would be exoplanets. So it's going to do a lot of study of exoplanets and being able to study the atmospheric composition of planets that pass in front of their parent star. And what that allows us to do, this transit method, is it allows essentially when it passes in front, there's a dip in light.
Did you call that transient method?
Transient.
Okay,
Transit?
yeah. No, that was transit method. But
method?
I just, I was looking at my notes, and then I was looking at what was written in chat, and so I think I missed you saying transit.
Okay. No,
method.
I said that.
Yeah.
And basically, they can see kind of through the thin like band of a planet's atmosphere. And the first like kind of test. These, by the way, all these images that were released. They're like test images. They're just like, let's just see let's take some pictures of what's representative of what we're going to be studying, and just see how things are working.
But there's real science.
But there's
in
real
these
science that
images.
have come out, and so they looked at an exoplanet, WASP 96b, that's 1,000 light years away, which is really far to be looking. Which is a really far away exoplanet, and they were able to find water vapor in its atmosphere using an instrument on Webb, the single object slitless spectroscopy.
Yeah, you better say that right.
Yeah. And so you can see this isn't like ooh, it's so pretty, but this is data. This is actual scientific data that is showing where the water molecules in the atmosphere are blocking the sun's
or
light,
absorbing it.
absorbing that light.
Now, before you get excited and you see all this water that's in this atmosphere, this is a planet that is about 20% larger than Jupiter, so it's 1.2 times the size of Jupiter.
It's bigger than Jupiter and closer to its parent star than Mercury. So it's a hot, big, gassy boy.
It's what we call a hot Jupiter. It actually goes around this sun-like star in a matter of just a few days, and so it goes really quick. So it is too hot for any kind of life to exist, at least life as we know it, on this planet. However, what this does show is that we can look at the atmospheres of other planets, Earth-like planets, planets that might be in that habitable zone around its star, and see if there's water vapor in the atmosphere, and also, more importantly, see if there's things like methane in the atmosphere. Why is methane important?
Farts.
Well, pretty much, yeah. So the thing is methane does not exist long in the atmosphere. Ultraviolet light easily breaks it up.
So you have to have a source replenishing that methane, and if that methane is constant, then there's something
it's replenishing it.
That methane. Now, that doesn't necessarily mean it's always 100% of the time of a biological
there are geological processes that do it.
However, I assume they can use the spectra they find in these Earth-like planets and do basically planetary there's like a comparisons and be like, look at like maybe the atmospheric makeup of our planet and go, oh, this is fairly similar, or or they can try and figure out, well, what could be the source of this based on other aspects that they're finding of the
so if there's like an alien civilization that has their own Webb telescope and they're looking at us, they can look at our atmosphere, and if they've been studying us a while, say for the past few hundred years, they're like, holy crap, they're putting a lot of carbon dioxide in the atmosphere. What's going on there? But there is also a significant amount of methane, and they might be able to infer the existence of cows, or as Jack calls them, astrobovines.
Astrobovines. I love that. Astrobovines.
So, yeah.
But also, what is interesting, though, is say like WASP here, we're seeing its atmospheric composition as it was 1,000 years ago, because this planet is 1,000 light years away. So we're not necessarily seeing the present state.
No, we're definitely not.
Of said objects. However, 1,000 years ago, we were still here on this planet. Our climate was better, but or not.
Climate's better.
No, downward spiral.
The existence of life is. Humanity. They had a shit existence.
Well, yeah. But. I don't know. Anyway. Whatever.
Yeah. So basically, if there is a habitable planet at WASP 96, and they're looking at us as we look at them, we're both seeing each other as we were 1,000 years ago. So they're seeing us, before the Industrial Revolution, long before the Industrial Revolution, and so our atmosphere was a very different consistency. So what I haven't looked up in a long time, but I know that like a long time ago, the carbon dioxide was 400 parts per million or whatever in our atmosphere. 1,000 years ago it was much less than that.
Yeah, and so over time, and this is where this kind of science takes a long time, because just for confirming the existence of an exoplanet, you need 3 transits, and depending on how far away the planet is from its parent sun, that could take several years to get the confirmation.
Right.
that planet is there. And so when we find, like, when we look at the atmospheres of these planets, as long as we have this kind of technology as a presence in space, we can study those over decades, and then maybe we notice changes happening, or that could be due to the advancement of societal evolutionary processes on a planet or something. We can notice those changes and be like, okay, there's something happening here. But of course that's going to take like decades long science.
And that's the power of Webb.
Yes.
Webb is going to be able to look at these planets and look at their atmospheres, and this is one of the things that I was really excited about with Webb, being able to see the atmospheres and study those atmospheres, and actually even to confirm an atmosphere. So WASP 96b has an atmosphere, obviously, by the data that we have, but we're going to find some planets actually don't have them. And that will be able to be picked up or discovered, whatever it is you want to call it, when Webb is actually watching this exoplanet transit its star.
Federico says, holy cow is what we literally say when we discover methane in an exoplanet. I love it.
Universe of cows.
All right. Onward and upward.
Hey, sure. You're in charge.
We're 1,000 light years away right now with WASP 96b. So let's go ahead and go a little bit farther out there, about 2,500 light years away, with the Southern Ring Nebula.
I love how, like, I just put this, like, in just increasing distance, and it instantly becomes the outline of the show.
Whatever works, right? So the Southern Ring, there's also a just ring nebula.
And that's in the north.
Southern Ring is in the southern hemisphere. And this is what's known as a planetary nebula. Nothing to do with planets. Thanks, astronomers. But this is the future of our sun right here. Basically, sun-like stars, when they run out of energy, their cores begin to shrink. They can't hold on to their outer atmospheres, basically their outer layers, and those layers just start to like puff off. It expands, and then they just kind of slough off into space, and what remains is essentially the burnt out core. Now it's just kind of radiating away its leftover energy. It's not making new energy, and that is now called a white dwarf, which you can see in the center of this image is the.
It's what our sun will become. Basically, this is the future of our sun.
That's what I said.
Oh, did you?
That, yeah. And so with the Webb image here, you can see all these different layers of that material that has been sloughed off over time, poofed out into space, as you will. And we can see all this texture and detail there, and all these elements that are present in this are going to head off out into space, come in contact with other areas of gas and dust, and new stars and planets and moons and asteroids and what astrobovines will eventually come. I'm not changing it. I'm just getting prepared on what I want to.
What I really like about what I really like about this is this is going to go on our wall somewhere, but at some point, this is a beautiful image showing you the Southern Ring. But if you look beyond the Southern Ring, you can see galaxies in the background.
Yeah, and some of those galaxies, they look like they're in front of it, but we're actually seeing through that dust and gas that's there, which is this highlights the beautiful capabilities of Webb, is that you're not just observing the Ring Nebula. Somebody who's studying distant galaxies can also use this as data as well. They can glean information about these galaxies behind it, and you can see like some that look like little like frisbees in there, little discs. We're seeing them edge on, like the one on the left-hand side, left-hand side of the image there. So it just has so much detail, and this image is with near, but if we look at it with Miri, that's not the right. Oh, I messed up my images. All right. I don't know where to put it.
Just real quick about these images that we see here. So you can see some foreground stars, stars that are part of our galaxy. And when you look at a James Webb image, those galaxies are going to have basically the little spikies coming off of it. And in general, they're going to have 6 large spikies that come off of it.
Okay, so I don't have the MIRI image because I attached the wrong image file. But in the MIRI image, you can see another star there in the center, and so it's a binary star system. And so one star is younger. It's still actively going. Where
and it's the brighter one of the two. So if you do look it up,
actually, so this star in this near image. That is the not dead star.
That. Oh, that's a good question.
Because the Death Star was redder, I think, right?
Yeah, that's probably going to. Wow, that's a good question. That's probably.
We don't know which star that is. We didn't look it up ahead of time.
Gosh, I'm gonna. I don't know. I don't want to say the wrong thing. My gut is telling me that is probably the active star, and
because of how bright it is.
Well, how bright it is, but also I think the white dwarf's a little bit to the left. But I'm not sure.
Chat, you can look it up, Google it, and let us know.
Oh, it's too bad we don't have that other picture. That picture is beautiful, and you should look it up, and you can actually see stars, more distant stars. You can see it in the dust, and it's because these different wavelengths show us different things about the universe. We're able to see through dust a little bit more.
Okay, actually, you know what? Let me.
You can do it this way.
Yeah, I'm just gonna bear with me here.
We're all bearing.
All right, cool. Then let's do this. There we go.
There we go. All right.
All right. So now you can see the 2 stars that are in the center.
That's hard to say. That's hard to say whether that's I'm trying to look at the filaments and stuff. But anyway, so on the picture on the right, it shows you the where you can see the 2 stars. The bluer material on the right is actually hotter material, and so this is just an incredible freaking image. I really love this.
It really highlights like how important looking at not just visible, like what we can see, like it shows, and it really shows how much is hidden from us, how much we can't see. That's what I really mean to go with it, and. It's almost like kind of you can think of it as, perspective. Like there's so many different perspectives, and the importance of looking at different perspectives to really understand, apparently not just the universe but each other, and that's
why I was saying it's a larger.
Yeah, there's a larger social commentary for this. But anyway,
and this is just near infrared. And mid-infrared. I couldn't think of mid. Medium was the only thing that's going to
medium. It's medium infrared.
This is just
well done infrared, medium infrared.
Exactly. This is just near and mid. That's all it is. This is not far infrared, and it's not even the energetic forms of light, like X-rays and gamma rays.
Those gammas.
Or even ultraviolet light. Those will show us just entirely different processes. So, to understand really and truly how the universe works and how these things develop, you do need, like you were saying,
a spectrum of technology.
A spectrum of technology, because they show you different things. Like, if we're wanting to look at Sagittarius A star, the supermassive black hole at the center of the Milky Way, you're going to need different instruments to see different things for it. So,
Jack says the wee little galaxy that was not blocked by the right was actually behind gas. yeah, a lot of this stuff is hidden from us. It's we can't see through the gas and dust, and so we're seeing features in these objects that we've never seen before. And we have a good example of that coming up later. But next, we're gonna step out. Oh no, actually no, it's coming up next. Just kidding. I forgot we were going in order.
And you can do whatever you want.
I know, I can. But let's go 7,600 light years away.
Are we gonna do smacks? Is that what we're gonna do? Smacks? We're gonna do smacks now?
Oh, is that what? Oh,
That's
did I
the
smack
deep
you?
field.
Oh, okay.
No.
No, we're gonna go 7,600 light years away to now. When the Hubble image of this nebulae came out, we were like,
Oh my god, yeah.
it's amazing. But now this comes out, and we're like, holy fuck, Webb! God damn, this is gorgeous.
Yeah, and this is only a small portion of the nebula.
Yeah, this is the
isn't
Carina Nebula, and it's a stellar nursery.
Mhm.
And the majority of these stars in this picture we've not seen before because they're within the gas and dust of this nebulae. They were hidden from our eyes.
That Webb can see. Webb can see through that dust.
And the redder stars are the younger stars. They're forming out of this gas and dust. We're seeing these baby stars for the first time, and these interesting like structures within this nebula that they're like, what's going on here? What is that? Like there's just so much to
And there's so much to it. So basically, just to talk about what's going on in this picture.
Mm-hmm.
All right. So at the top, you have this blue nebulosity. You have some stars in it. These stars are just bombarding the nebula in the bottom half of the image with ultraviolet light, and you can actually kind of see that boundary here. And what do they call this thing? What do they call it? Oh, I didn't write it down. They call it like cosmic cliffs or something like that.
Oh, the cosmic cliffs.
The cosmic cliffs.
Take that, cliffs of Dover.
Yeah, we're calling you out, England, for some reason. I don't know why. So these stars are just bombarding the nebula with this ultraviolet light.
Eating away at it.
It's eating away at it, and so it pushes it down, and that does two things can happen. It can actually stimulate star growth. I mean, so you can actually star formation. That's the word. But it also can hinder it as well. It can evaporate.
Because if it evaporates it, then.
So there is this like beautiful balance between formation and destruction with this right here. The blue nebulosity is this ionized dust that is being shot out of the nebula. It is coming up off the nebula from all of that ultraviolet.
Can you relate it to like say steam coming off a lake or something in the? Not maybe chemically, but
I don't. The processes are different. They're very different, but the processes are very different. But it's kind of like
the same that's how visual effect.
Visual effect. Yeah.
For visual effect.
And so with like NearCam, you can see all of these stars that we had never seen before. With MIRI, you can actually see. In these images, they can see photographic.
Do that.
You can see the disks where planets are being formed, and the younger stars in these MIRI images tend to be redder in color. There's all these structures that they don't understand, and I believe I've heard. I heard somebody say, and something that we listen to, so this is not us that is saying this, but Webb is giving us answers to questions we don't even know to ask.
Yeah, this is stuff that, future science, like, that just by studying it, it's going to be like, it's like we're gonna learn something, but then there's gonna be these more questions that we're gonna have, and we don't even know the possibilities.
We know the answers. We don't know the questions, which means we don't understand the answers.
Especially when this is just the beginning. This is just these were just like test images. So these weren't like anything that they were like specifically taking these images with the intent to do any specific research or science on. Because that is coming up.
But
it wasn't like, okay, we're going to focus on this area for this long to find out X, Y, and Z, and it's when they start doing that, that is going to be, you're going to get so much, it has the capability to give us so much data that...
Yeah, basically, they took these pictures... This is astronomy porn right here. They took these pictures to get everybody excited to see the beauty and to see the different ways in which we can use the telescope. There weren't any real scientific questions, generally, behind these pictures. It was like, we take the picture, we see what happens, and whatever comes of it, comes of it.
And then as scientists are looking at it, they're like, wait a minute.
Yeah.
What's that?
But going forward now... There are scientists that are lined up that will use James Webb that have very specific questions and hypotheses that they're going to get data for. Can you imagine being the first scientist? You're the first one in the queue that gets to use it.
You're like, ha ha ha.
Yeah.
I better not break it. My mom says it seems like there's a ton of activity in the center of the pic. Baby stars.
Yeah, those are baby stars.
Baby stars, those bright red ones there. Those are baby stars that are forming out of that gas and dust. They're like, hey.
Yeah, and it's just all kinds of structure in it. I believe that I either read or heard this image right here is about 16, 17 light years across.
It's the main image. 17 light years across. 7,600 light years away, so we're seeing this nebula as it was 7,600 years ago, which means, what are the chances it's still there today? Oh,
why you ask me that when I have... it's still there. It's still there.
It's still there, okay.
Yeah. Those stars aren't going to evaporate that quick.
Okay. Well, I don't know how long it takes. Anyway. All right. Let's step out even further. We're going to go 290 million light years away. I have to find where I got it in the list here. Cool. There it is.
All right. So, bonus Cosmos with Cosmos points. You don't win anything. If you can tell me where this was seen in pop culture. Put it in chat if you know where it was seen. We'll come back to it in a little bit. But here we have 5 galaxies,
I don't know where it was seen.
It's in the notes, but don't read it out loud.
Oh.
So here we have actually it's 5 galaxies. We have 4 that are on the right side of this image, which is actually Stephen's quartet.
Okay. Quintet.
Is it quintet?
It's quintet.
Okay.
It's supposed to be quintet.
Oh yeah, it is quintet. It is quintet. But these 4 are actually
in the cluster together.
In the cluster together. The one on the left-hand side, where you can see all the stars, is closer to us, but it's also not part of those other 4.
Right.
And those other 4 are in the process of what?
Well, they're not cannibalizing; they're merging.
Right, but still, they're colliding.
They're colliding. It's a galactic collision.
It is.
Well, because my favorite space term is galactic cannibalism.
Right.
So I thought that's what you were in. But I was like,
well, no, but you know the thing is, though, is they are going to cannibalize each other. In the end, ultimately.
Cannibalization.
Yeah. So this basically what you're watching is a very slow motion train wreck.
It's gorgeous though. This is why we stop for wrecks on the side of the
Yeah, but this is more beautiful without any kind of potential death and destruction.
Yeah, well.
So basically, the middle 2 are in the process of actually merging right now.
Yeah.
They actually are combining.
Yeah.
In the act of it, but the other 2, the top and bottom, are going to be
slowly coming in. And you can see the debris from the collision as that red kind of swath of jaggedy gas around it. It's just like this debris field from this merger that's happening.
But you know what's really cool about some of this debris? Mm-hmm. Is it star formation.
Yeah.
So from this incredible collision, and from this incredible collision, you get star formation. So it would be like 2 trains running into each other, and in this collision, you get another train car that gets produced. And so it's an amazing thing. It's a slow wreck.
Very slow.
But you know what?
What are we talking? Billions,
this is our future, though.
Billions of years.
Oh yeah, yeah. It's it's 2 weeks. It just takes 2 weeks.
This is our future with Andromeda. We're heading right for each other, and we're gonna eventually start this dance in about, what was it? Like 3 billion years or something.
A few billion years, yeah. And so the Milky Way will collide with the Andromeda Galaxy. And what is amazing in this, I have always found this amazing. Let's just pretend like each one of these has 200 billion stars in it. So you have 4 galaxies. 4 times 200 billion is 800 billion stars collectively in all 4 galaxies. As these galaxies collide, as they merge, only a handful of stars will actually collide with each other. And we're talking probably, in this particular case, less than 100.
Wow. Space
out of 800 billion stars. And it's because stars seem so large to us because we are so small compared to them. But they really are tiny compared to the distances that separate them. So they really just pass by each other. So when I was in a planetarium, I would, in the process of telling people this, I would say, okay, let's just pretend like we have one person on one side of this 60-foot dome and another person on the other side, and they have one handful of marbles, and they roll them at each other. Most of those marbles are just going to go right past each other, like ships in the night.
Yeah.
You might have 1 or 2 that hit each other. You might have 2 or 4. I mean, it doesn't happen in singles. It happens in pairs. But most of them, most of the time, are going to miss each other.
Yeah, which is really...
I just absolutely love this picture, especially the galaxy on the left, because you can see individual stars.
Yeah, it's like when we look at the other galaxies and they look like they have these smooth spiral arms to them, but then this other galaxy just looks like, real low res or something. But we're seeing all the individual stars in this galaxy, which make it and just really cool. But at the same time, as we're seeing all these individual stars in this galaxy, it also looks like in this image that just this grouping of galaxies just got in the way of a deep field shot.
Yeah.
Because you're seeing so many galaxies in this image behind them.
Yeah, there's hundreds of galaxies in it.
Just amazing. All right.
You have the other picture?
But there's something else going on in this. Okay, so here is the Miri image of the quintet.
Okay. I really love this one because what is one of my most favorite things in the universe?
Black holes.
Black holes. And you can see a black hole in this picture.
It looks like a big red star shining in the top of the image, but that is actually the energy
of a supermassive black hole.
Supermassive black hole, and this is the spectra that they were able to get from that black hole.
So all right, just to be clear,
we're not seeing the black hole.
This is not of the black hole. This is of the accretion disk around it.
Yes.
And so it's amazing. I mean, look at this. Iron is only made. All of these elements that are in this, these are only made during supernova, during heavy stars, and they get ejected out into the universe during supernova explosions, and so you get iron and oxygen, all that kind of stuff. Molecular hydrogen is really the only thing that is not ejected from supernovas. Those were basically created in the Big Bang. This is the only way that hydrogen was created.
It's the Big Bang.
Big Bang, yeah.
Yeah, because stars make helium.
Yeah.
They start with hydrogen.
They
start with hydrogen.
This is amazing. I mean, look at this. We can actually with Webb look at what the accretion disk is made out of. And this is supermassive black hole, and it is in the top galaxy. in this image. All right, any guesses as to where this galaxy was seen? This quintet of galaxies was seen in pop culture.
Now that I know what it is, I can see the scene.
Okay, so think of God
Nothing
and
recent.
an angel talking.
Something old.
Yeah, it is
Something black and white.
It is
Something wonderful.
It is when God and his angel, was it Gabriel? I think it might be Gabriel, that is talking in It's a Wonderful Life.
About Clarence.
About Clarence, yeah. And Clarence actually comes in, whoop, really quick. It is my favorite Christmas movie. So this is the galaxy. Clearly, they did not use this image.
This image? No. All right, let's step out to the furthest we can go. Or have gone so far.
Oh, Federico cheated.
That's fine. You didn't submit your cheat guess though, so.
So very good. I love the honesty, Federico. I love it.
But of course, awesome. The very first image released was Webb's follow up to the Hubble Deep Field, the Webb Deep Field. In which you were seeing hundreds of galaxies and galaxies as old as 13.9 billion years. And those ones are real tiny and real red in this image. But what is striking about, I think what stands out the most about this image is that in the center you can see this bright white grouping of galaxies, but then going around it, it's like you're seeing these galaxies stretched and warped in this circular pattern around it, and those are galaxies behind.
Oh, but much further
away, much further behind, but the mass of the grouping of galaxies is bending space-time. It's warping space-time, so that background light from the galaxies basically warps around it. So we're kind of like seeing it come through in this lensing, which is gravitational lensing. Thanks, Einstein.
Yeah. Einstein proving right again.
And there's even they've been able to look at the spectra and find that there are well, I can't describe where they're located, but there's two, they found some galaxies that are warped that are actually the same galaxy, but they look like they're two separate galaxies because they're spread out from each other. But they're the same galaxy because they have the exact same spectra, which the spectra is gonna be like a fingerprint.
Yeah, it's a fingerprint.
It's going to be unique to that star, to that galaxy, to that exoplanet's atmosphere, that sort of thing. And so by seeing the exact same spectra, they're like, oh shit. This is the same. These are the same galaxies, but we're just seeing them in this warped way because of gravity.
But it's not just the spectra. It's also, well, it is. I mean, this is part of the spectra, right? It is that it's shifted in the exact same amount.
Oh yeah, same red shift.
Yeah, I mean that's in addition to exactly what you just said.
You would have.
Okay, before I actually comment on this image, I just want to reach out to. President Joseph Biden. President Biden. Mr. President. We did vote for you. Next time you actually release one of these web images,
maybe
consult us as to how you should actually present it.
Put it full screen.
Put it full screen.
Program directors for the White House Media Relations, whatever. Put it full screen and maybe have someone just say a little bit about what's happening.
Yeah,
but put it full screen, most importantly.
And instead of talking for 10 minutes, why don't you show the image for 10 minutes if you're only going to have an 11-minute
We're
news
sitting there and
conference.
we're like, stop, we get it. It's important. It's historic. Blah, blah, blah. Show the goddamn image.
Not to mention you were an hour late.
Yeah.
So,
Anyway.
All right, so the foreground image, the foreground galaxies is SMACS 0723.
Oh,
yeah,
SMACS.
I don't know what SMACS means, but it means something. But what is really cool is, so I think for Hubble's ultra deep field, it was staring at a point in the sky for
2 weeks.
2 weeks.
2 weeks.
2 weeks. 2 weeks.
I will never stop looking.
So this image combine over several different wavelengths, 12 and a half hours.
Yeah. Like,
And so I really love how I get what they're saying. The web team is going like, hey, we're able to do before breakfast
yeah, that's
what
their
Hubble
whole
did
thing
in
before,
2 weeks.
done before breakfast.
I love the throwing of shade. I really love the throwing of shade.
Hubble. Get it done before breakfast.
But this is an image that they took in 12 and a half hours.
Yeah.
12 hours. That's
Yeah.
all it is.
I mean, imagine if they looked at for 2 weeks.
Oh, I know, right? So the foreground is the galaxy SMACO 723 is 4.5 billion light years away. The most distant galaxy is 13.1 billion, which is only 700 million years after the Big Bang.
Yeah. This is the spectra. So you can see
so it does show
them highlighting one tiny little pixel. That's why I wear my Pixel Planet shirt. One tiny little pixel, which is an entire galaxy, 13.1 billion years old. It's 13.1 billion light years away, and we can see what's in its atmosphere. What is, or not its atmosphere? It's not a planet. But what's in it? Oxygen, hydrogen, neon. I mean.
Yeah, and 700 million years after the Big Bang, you expect to see a lot of hydrogen. Mm-hmm. But what's really interesting in this is the strong showing of oxygen. Mm-hmm. We need oxygen. If there's oxygen, I'm surprised they didn't show it, but there's probably carbon, quite a bit of carbon that's in this as well. This is 700 million years after the Big Bang, which means that you had to have had some really big stars really quickly go through their lifespan and explode and eject all that oxygen
to provide
out.
oxygen to the universe. Really, yeah. I mean,
so there's a lot of star formation going on. A lot of stars in the early days. Stars popping on and off and seeding the universe with this oxygen. And this is just that galaxy. Guess what, folks? This is going on. This happened in our galaxy as well. It's not like you can go, okay, that happened there. It did not happen here. Obviously, it did.
It's happened
because we're here.
Yeah.
It's not like we showed up in a vacuum.
We're not in a silo of our own physics.
Right.
Like
we are children of those oxygen lines and those hydrogen lines and the carbon lines that we don't see. We are children of this that happened 13.1 billion years ago.
Yeah, this, seeded the air you breathe.
All right. Wait a minute. I gotta catch up on the chat.
My mom had asked about the light with the spikes, which are stars. So stars, when any telescope, whether it's Webb or Hubble or just regular telescopes, but stars in these images, they will always have like this kind of spiked snowflake pattern to them, and it's with how the mirrors are set up and everything. You get these refraction spikes, which when they're studying a star they can calibrate to adjust and remove those, but in images like this you get these refraction spikes. But it also is actually helpful to then be like, oh, clearly that's a star versus that's a galaxy. And with Webb it's always going to be 6. You will have the middle part, but you got the 6 big ones, and that is because as Federico said, it's the pattern of the mirrors.
Yeah, the mirror is a hexagon, so it has 6 shapes, 6 sides, and so 6 little spikies.
All right. I'm gonna switch over to we're gonna do a little comparison.
Hubble and this is gonna be great.
So here's what we're gonna do. We're gonna compare the Hubble images with the James Webb images here. So there was a website made, like this tool that was made, webcompare.com. Webb, of course, spelled with 2 B's for James Webb. I don't have the name of the guy that made it. Edward something, I don't know. But anyway,
show Hubble.
So here is the Southern Ring Nebula.
How big is the Hubble mirror?
Oh God.
I meant to look this up, and Hubble has been amazing. I don't mean to shit on Hubble. It has been amazing. It's given us incredible.
Hubble is the giant that James Webb is
stands
standing
on. Right. So Newton said, "I stand on." The reason why I can see so far is because I stand on the shoulders of giants.
Mm-hmm.
That is what Webb is doing. Is standing on the shoulder.
We would not
of
have
Hubble.
Webb if we didn't have Hubble and the success of Hubble.
Right.
Because if Hubble had major issues where its eyes didn't work. They had to fix it and put glasses on it, basically. But if they weren't able to fix it, it would have been it would have been space junk. And then the green light for funding for Webb may never have gone through. Like, we may not, that could have kiboshed.
Right.
Future
Hubble,
exploration, by a long time.
Yeah, Hubble is so amazing. I am getting a Hubble tattoo eventually. But when you look at the Hubble image and compare that to the Webb image, it's mind blowing. It brings like literal tears to my eyes. It is, and I'm using that correctly, by the way. It might not happen today, but it did.
I see they're watering.
Yeah, it did when they were showing these pictures. It's just amazing. So this is the Southern Ring Nebula with Hubble.
But I also want to keep in mind that Hubble looked in visible light.
Right.
Whereas Webb is looking in the infrared, which means it can see, it can resolve more detail. It can see, it sees differently, and so it sees differently than Hubble. So it's not necessarily an apples to apples comparison, but it's also an apples to apples comparison.
But even though it sees differently, it still sees so much more.
So Southern Ring Nebula with Hubble, we can see these structures. We can actually see there are two dots in the center. But I don't know if that is
it
is equatable. Okay, so you can see the white dwarf is the smaller one, whereas the active star in this system is the brighter one. And
by
and
active,
notice,
we mean that
it's nuclear fusing.
Yeah, it's still fusing elements.
It's doing
in
nuclear
its core.
fusion. It's creating energy. And notice the blackness, nothingness of space around it.
Well done.
Compared with James Webb.
Oh my God! This is a near cam image.
And it's like
just,
the universe comes to life a bit.
It really does.
You know?
I mean, because you can. I just can't emphasize enough. You mentioned the blackness of space. It's not black. It's there's stuff there, and we can see it now. Yeah. Granted, in the infrared, I really wish I could see the universe in infrared. I don't know, can cats? Cats can see. I don't know. They see ghosts.
Cats
but anyway,
can see the universe.
But I mean, there's galaxies in this image. There's star death in this image. This is and just the textures alone. I mean, if you look at the Hubble image, you see, hey, it looks like maybe I can see like 3 or 4.
You can see like some of the puffs,
Yeah, you can see like 3 or 4 of the puffs.
Some structures in here.
And that's what you can see.
The middle stars.
But when you look at it with Webb,
you really get that detail.
There's so much texture to this.
Snakes can see the universe too. Thanks, Jack.
Yes, fuck snakes.
Why'd it have to be snakes? This galaxy is one I was referencing earlier, where you could see it like edge on in the background, behind this nebula, through this gas and dust, and it just reminds me of the Sombrero galaxy, because we see the Sombrero head edge on like that, and so
I just can't emphasize enough how much Webb's going to change our view of the universe.
Ready to move on?
Yeah, always. Oh my God.
So Hubble took just a small view of the Carina Nebula, so you can see that's how it extends all the way out here. But I mean, which is in itself a gorgeous image. Like, you can see a lot of structure in the Hubble image. You can see
Yeah, but it's a bit muddy.
Evaporation.
It's a bit muddy, but yeah, you can see that. Yeah, like you said, the evaporation. You can see some of the like elements and
Like
the
in
structure in it, like you
here.
say.
But a lot is hidden in here. We're not seeing through these darker areas of gas and dust that are here. But then
And look,
look,
there's
you
stars that we can see.
all these stars, all these pinpricks of light that just really resolve themselves.
Yeah, and even in the infrared, there's so much more structure to it. Even like in the blue part. All right, that's what I mean. In the blue part,
The
you
blue
still above the actual nebula
Yeah.
itself, you actually see more structure. This is all I can say, these are fucking amazing.
And we again recommend everybody to go and download the like highest resolution images versions of these, and like you can zoom in and just like get lost in space, basically.
Which I have to admit, as soon as they put them up, I did.
I tried to download the super high res ones to put in for the podcast, but OBS couldn't. OBS was like, "No, I'm gonna shut down now because I can't handle the size of these images." And I was like, "All right."
Let's go to Smacks.
Smacks. All right, so Hubs. I mean,
All right.
Hubs is. I mean, look, you can see some gravitational lensing.
Yeah, you can see a
here.
little bit of arcing.
You know, you see.
And by the way, the foreground galaxies look a little bit more orangish in this image. So just keep that in mind. But yeah, but look how it explodes with galaxies, and those arcs become even more prominent with the Webb image.
So
I
great.
I love these arcs. I love them. All right, so I am a gravity fan. I am an Einstein
You're
fan.
a fan of gravity?
I'm a fan
You like
of gravity.
it holds you down?
I like how it holds me down. It's like that shack on Elden Ring. It just holds me down. So
Are we gonna have to add a new
we're
Elden
gonna have
Ring
to add. We're gonna have
rule
to add
now?
it. So we're obsessed with Elden Ring, and we play it like daily. Liz will come upstairs, get on our other Xbox.
Yeah, because God forbid Xbox allows you to play together in the same,
and we have our headphones on, and we're just, hey, let's go kill some things in Elden Ring. But anyway, I just love the arcs.
Yeah, that's my favorite. My favorite feature is the gravitational lensing. It's just so cool.
It really is.
How gravity works.
Yeah. I mean, when you think of like lenses, you think of pieces of glass. You don't think, typically most people don't think that gravity can act the same way. And you can't fine tune the gravity of the galaxies, the foreground galaxies, to make these the more distant galaxies come into like a focus. I don't know if that makes sense.
Yeah.
I've had 1.5 of these drinks.
No, I mean, no, like a camera, you can adjust your.
And so and so what happens is you get these arcs, and it's just amazing. Like
I really like this one
Yes.
right here. This little
Yes.
smear of
I
a
was
galaxy.
gonna say.
This is like one of my favorite little smears.
I was gonna say, because you can see the galaxy in that smear.
Yeah, you can see it. Okay, here's the central bulge. Here's a spiral arm. You've got another spiral arm. Like you can actually see the structure of it, but it's just like fucking been like stretched Armstronged.
Yeah.
You know?
Is
that too old of a reference?
No, I get it.
Okay.
I get it. I always wanted one.
Gumbead?
Gumby's another good one. That is what, no pun intended, or maybe.
Always pun intended. What household do you think this is?
That was the arc that I gravitated to.
Pun intended, 1,000%. I know you don't like more than 100%, but 1,000%.
That was the first thing I noticed, and I noticed immediately how
That was the first thing my eye was drawn to too. I was like, "Holy shit! Look at that! What's like on that galaxy?"
And you immediately noticed that. Oh shit! This is oh god! Even in its arc, I can see that it's a galaxy.
I mean, like, look at. I mean, it just kind of looks like a blah, but here you're like, oh.
It's so much brighter
nice.
because the mirrors are bigger.
Gumby's older than Stretch.
Okay.
All right. So I went. I'll go more recent, Gumby.
But I do remember Stretch Armstrong as like Christmas gifts.
I think I wanted one, but I don't think I ever got
one.
Just like
Stretch?
Power Wheels. I still hold a grudge against the Power Wheels. I shouldn't.
Wait a minute. You hold a grudge against the Power Wheels or against
Power Wheels? I always wanted a
your
Power Wheels.
parents for not getting you one.
Well, I don't really hold a grudge, but I always wanted one. And yesterday not yesterday, but the other day when I was doing the weeds out front, a little girl drove by in her Power Wheels, and I was like, God damn it, I don't want Power Wheels.
Well, I know what I'm getting you for your birthday.
I can't fit in one now, but I'll try. Anyway, all right. Galaxies.
Right, the quartet.
Do I want a Barbie car? I guess. All right. Hold on.
Yeah, let's do Hubble.
Hubs, which
It's
amazing
not bad.
image. I mean, look, you can see this starbirth.
Yeah, you do see.
You see starbirth that's happening. You see this like deformation. So this debris field. You see how these two galaxies are currently like really merging together. You can see a little bit of the resolution of stars here, but you see more kind of that smooth dust and gaseousness. I mean, this just looks like a good normal spiral galaxy right here. You see stars, and you can see little pinpricks of distant galaxies.
Well, you assume that they're...
Well, you assume. You don't know,
Yeah,
right?
some of these pinpricks, I mean, at this point in the game, you're like, yeah, these are probably pretty much galaxies. But when you expand out to Webb, this is just... Some of these galaxies become a little bit more alive, if that makes...
Yeah.
But, I mean...
Like, look at this galaxy right here, which on the podcast, sorry. It looks like just a little red dot, but then with the Webb image, you can actually see its elongated disk shape. So you can actually go, there we go, that's a spiral galaxy right there.
Right. And let's be honest, for galactic astronomers that are interested in galaxies, Webb is really going to... Holy crap, there's so much that they can explore.
Watch this debris, what I am now calling the debris field.
Just explode.
Just like explode.
And, I mean, it's just amazing, all the details, especially in the galaxy that is actually not part of the four. Just really how you can see the individual stars. Let's be clear, this is not the first time that we have seen an individual star in another galaxy.
Yeah, oh no.
No, I mean...
It's just like the breadth of...
Right, I mean...
Now...
Edwin Hubble, the namesake for the Hubble Space Telescope, was doing that 100 years ago.
Yeah.
But it's just amazing to look at this other galaxy, the closer of these five, and to see them. But then to also just change instruments on your telescope and see the supermassive black hole.
And see something completely new or
different
or
unexpected
or...
I'm so excited. I really think that every episode now should be James Webb. What did Webb do this week?
It's exciting because it just shows like what just the new shit we're gonna learn and see and discover. It just expands that frontier, or at least maybe like what's capable of us exploring that frontier.
Right. NASA should have never told us that that deep field image was taken in 12 hours, because now I expect 14 deep fields every week.
So many deep fields everywhere. We're drowning in deep fields.
What are you doing, NASA? Come on. So, I mean, it's exciting. It really is exciting. I can remember in 1998, 1999, right around there. It was like, wait a minute, what? You discovered dark energy? What? With Hubble? And Webb is going to take us to the next level with all of this, and it's just, put your seatbelts on, or if you're riding Cannibal at Lagoon here in Salt Lake, we get this reference. Brandon will get it, but you don't get a seatbelt, you just get a lap bar. Hold on.
Or my favorite phrase, hold on to your butts.
Yeah. So the question is, how often do they think that new images will be posted?
It just depends on...
It depends on the scientist.
Yeah, when they're using it, how they're using it,
Yeah.
So
the thing is, generally...
They might have a schedule posted online, or they might have something...
Yeah, but still...
schedule.
Alright, so... In the past, I don't know how Webb has it set up, but in the past is that you would get observatory time, and then you have access to that data for a year, and it's embargoed for a year. And so that means that it does not need to be released for a year. It doesn't mean that...
They're not going to release...
Yeah, I mean...
we can't answer that question. We don't know. We don't know when they're...
I
didn't know they were doing the Jupiter picture.
Right.
I happened to see on Twitter, Jupiter references, and then, someone had said James Webb Jupiter. I was like, what? Where? And I actually went to, the James Webb website, or the, 3 of them run by different people, and I was like, I couldn't find it until I found it. No, I found it just in, some article, and then I was like, oh, shit, that's awesome.
Yeah, so it's gonna depend on how the image is made. So it's not like, you have... astronomers have a 12-hour block, and then you move on to the next astronomer for 12 hours. It's not like that. And so there's going to be time between in which they can get pictures. And they're going to take pictures.
Yeah, and they probably will have time where they take pictures for media relations, for publicity,
and that's built in.
Stuff.
And there's going to be times where something happens, and an astronomer that had time is going to get bumped a little bit. They're going to be pushed back.
Right.
But, it's going to be a fun ride.
I guess just wait and see. Well, keep your eyes on the news and, follow James Webb and on its things. And therefore, also follow us on all our things. I think... we'll call it. We'll head into the hangover after this, but we have done I think I'd say a pretty lengthy review of the images, because we're so excited about what they mean and what the tales they have to tell, and the future of space exploration and our knowledge of the universe.
Right. So join us in 2 weeks. We don't know what the topic is, because we don't know if Brandon's going to join us.
Yeah, so we'll find... Well, all right. Well, yeah. But in the meantime, check out episodes of The Shot every other Wednesday, and follow us on all the things. Thank you guys for joining us, and if you're with us now, stick around for The Hangover with Cosmos.
Cheers.
Bye, everybody.
Technically, we need a drink. Cheers.
Oh, because the dog just barked. Drink! Last minute drink! All right. We'll see you in a minute. Be right back.
Okay, I have to start with this. Federico says, this is a quote. If the universe is the answer, what is the question? This is Leon Letterman. What makes me scared, and this is Federico, is not the answer, but the amount of new questions will
Images
rise.
will rise.
So, Leon Letterman is a Nobel laureate. He worked at Fermilab. He had to sell his Nobel Prize to pay for medical shit because his country's fucked up when it comes to medicine.
Wow.
But I don't think you can see it, but autographed by Leon Letterman.
Oh, hey, look at that.
Right there. Oh yeah, I guess you
How
can't
do you
see
spell
it.
your last name? It looks like it says like Genji.
No, it says George, George. I think the O and the R are a little bit combined. Best wishes, Leon Letterman. So he came to Clemson University to give a colloquium,
Colloquium?
a physics talk.
Oh.
And we actually got to meet him.
Oh.
They canceled classes for us, and we got to go meet him and sit in a conference room with Leon Letterman and basically just have a conversation with him about physics, what inspired him to go into physics, and
it's like Christmas for you.
It was. I mean, I literally sat across from a Nobel laureate in physics, in quantum physics, in particle physics, which is at the time, which is what I was interested in, which was what I wanted to go in, because I wanted to be part of the team that found the Higgs boson, but actually also fell in love with planetariums.
Planetariums.
So
damn domes getting in the way.
It's yeah. So Leon Letterman, thank you, Federico. I don't know if you're still with us. But thank you.
He didn't die. Oh, he's
yes,
still here.
yes.
Aww.
Hey.
Oh, I like science disseminator.
I like that. Right here. All right, Federico. To Letterman. Federico to Letterman.
Jack went to Maya Angelou colloquium. Very cool. Man. Oh, I didn't cheers to that. To Letterman. Not David.
No, this is spelled differently.
And apparently Brandon is somewhere in the skies. His metal tube he's in has terrible connection, he says, currently. But apparently he's trying to
join us.
Observe in some form.
Making sure we're doing okay?
Yeah, he's checking in on us. That's
checking
sweet.
in? Yeah.
Checking in on us from his metal tube in the sky.
So, Federico, thank you. Thank you. That was not what I was expecting. I love Leon Letterman, and
he got real excited once we went to break, and he ran down the stairs.
I ran
and
downstairs
was looking for the book.
In fact, knocked over a column of books that we have on the bookshelf.
I gotta fix our decorative display of books that I made.
It's not gonna be hard. If you have not read The God Particle, you should.
I have not read the God.
You
God
should.
Particle.
It is about Higgs. Really and truly, is about the Higgs boson. It's a great book. Great book. If you love like quantum physics type of books.
Caveat.
Man.
If you're not into books about science.
Oh, I was gonna say I don't think there's any equations in
I
it.
think I just saw one.
Yeah, there's some in there.
Equations. Anyway. There's equations.
Oh no, these are in the notes.
But those are still equations that are in a book.
Oh yeah, but
anyway,
God, equations are
what
beautiful.
did we do the main episode about again? James Webb Space Telescope. We did the main episode about. If you did not see it or listen to it, go check it out on Spotify.
All the
things. And we show images, so if you want the visuals, then definitely look at the YouTube channel.
Did you say we sell images?
If you want the images.
Oh, okay.
If you want to see the images.
My ears do not work, and this is my good ear, by the way.
What did I just say?
Yeah, and so I'm like, did you say sell them?
But for now,
we're gonna sell these web images that are free that you can download for free.
But for now, welcome to the Hangover with Cosmos with Cosmos.
Welcome.
We never planned what we were, or even had a mention of what we were going to talk about in the Hangover because he got so excited about the Letterman book.
I really did.
I
did.
You know,
I ran downstairs.
There was a bathroom break that was needed, and so it was just like, well, here we are. We're still here. We still want to talk. So any questions you have about whatever, feel free to ask them and whatnot. But I have a question for you.
Oh, shit.
That I just thought of right this second.
There's too much pressure.
What? I don't know the answer to this question for myself, but, and I'll ask this to everybody out there. What is something that you're most excited for from Webb?
Oh, that's not fair. It's not fair.
Anything you think of as far as like science or just like a picture or whatnot, like something you would like to see or
okay.
Hopes and dreams for the future. I don't know.
I really want to see 2.5 things.
Okay, I think I'm gonna guess what one of them is.
All right, what is it?
Orion Nebula.
Oh well, yeah, okay, yeah, definitely so. No, yeah. So I mean, obviously, M42 is our nebula, as if we own it.
We own it. We have claimed it in the name of Davis and George. M42 will be ours.
We love this nebula. It's just incredibly beautiful.
It's a stellar nursery. It is like the first nebula that I saw through a decent, an 11-inch Celestron telescope that can resolve this shit. And it was amazing to see because I could actually see like how like I could actually see a little bit of structure in it, not like you get with the Hubble images and the colorization and everything because we can't see that. You know, but I could see the trapezium, the 4 brightest stars that are kind of in the center of this stellar nebula where stars are being born. And we saw it. My first time seeing it, we were at a star party at Alamo Lake State Park, and so we made it kind of like our nebula because we were sharing this experience together, and it was
so beautiful.
It was beautiful to see. So that's actually, I think, that my answer, even with all the amazing science and everything that Webb is capable of and is going to bring to us, I think just an image of the Orion Nebula from it. Like, I think that's what I'm looking forward to. That's what I want to see the most.
I would love to see it.
And I have no clue if they're going to or if that's on the docket or something. But
somebody's going to.
I think that's something I would love to see and what I'm looking forward to the most is just like seeing Webb's view of Orion.
And that's really like a hard choice for ours. Science is probably different, but I really would love to see the Orion Nebula in the detail that we have just seen Karina.
Yeah, and just like how many stars are in there, and just like what's like just the trapezium, and then just like the structure of it, and like
I really hope it's on their list. If it's not, hey, because I know the Webb folk follow us. Put it on your list. Brandon, make it happen.
It's
in your metal tube.
Fancy physics man, all right? They listen to you.
Scientifically, I think I would love to see anything that is closer to Big Bang. And anything exoplanet related.
Well, I mean, those are the two big ones. Yeah, it's like Big Bang stuff, distant galaxies, distant, like, universal evolution understanding. And, yeah, I'm really looking forward to, even though it's not like we're going to get, like, the pictures that the general public, I think, are wanting, or that's kind of what they relate to the most is just seeing the images and stuff. But it's that data behind exoplanet atmospheres. You know, it's like we've discovered over, what's the count at? Like over 4,000, over 6,000
Right.
exoplanets, and having the level of technology to be able to figure out what's in the atmospheres of Earth-like exoplanets that are transiting in front of their parent star, having the ability to really see what's in those atmospheres, or, you know,
Yeah.
is, I think that could be really, and it is, like, that is like the newest frontier we've embarked on in terms of space exploration, because just we haven't had the technology for it. And so that's like what's really going to be, could be like groundbreaking discoveries.
Right.
Is
Yeah.
seeing, oh shit, here is a planet that, hey, it has like very similar composition of nitrogen and oxygen, and
As
methane
Earth.
and carbon in its, you know, atmosphere, or at least our atmosphere at, you know, X time period, or, you know.
Yeah, and the only way you can explain some of these is that there has to be life that is making, like, the methane in the atmosphere, so forth and so on. Okay, so the Big Bang happened 13.8 billion years ago.
Which was was it Hubble that gave us that? What telescope? What was the data that gave us that current?
It's going to be a combination of
date.
telescopes, and at
Because
this
I
point,
think I remember working in the planetarium, and that knew that
Right.
they were like, oh, it's 13.8, not 13.4 or
yeah,
2 or whatever.
yeah. So I mean, it's Hubble, but then you also have this data is backed up by Planck Observatory.
It was Planck. I think.
Yeah.
It was Planck that did the
And
mainly.
then you have like the observatories down in Chile. So it's all right. So 13.8.
Okay.
And if Webb measures this, it's going to be pretty close to it. So 13.8. We see that galaxy in the Webb deep field at 13.1. What happens in those 700 million years?
A lot.
Obviously,
clearly.
a fucking a lot.
Yeah.
And so, really and truly, let's just say 300,000 years after the Big Bang, and that's when you get this like decoupling of energy and
You
everything.
get
And so,
the forces, right? Because
Well-
all the forces were one.
well, they split,
The-
but the energy of the universe cools down enough to where you actually can see the cosmic background radiation.
Yes.
This really
which is 300,000
thousand
years after the Big Bang.
and this is the wall. We
That's
cannot
just-
go beyond
yeah.
that.
We can't
even
see
with
past that because
Webb.
there's nothing to see. There's nothing.
Yeah,
We can
and
see.
yeah, so there's not going to be so that's the wall.
And physics itself can only go back to 10 to the negative 32.
Minus 42
The
seconds. It's
negative
the Planck
42
time.
seconds, yeah, after the Big Bang. So we
Which-
can't even scientifically go
Beyond
right up
that.
to the Big Bang.
So, but let's think about that for a second, though. 10 to
I
the
can't.
minus
My brain will
42.
melt. I'm gonna die.
So there is a 0.42 zeros, and then like a 1. It doesn't even matter what number you put
I
there.
think it's like 32 though.
No, it's 42.
Is it 42?
It's the Planck. It's the Planck
it-
link.
oh,
It's the
okay.
Planck time. Don't argue with
I'm
me.
just going back to my junior college astronomy class, and I'm not gonna argue with fancy physics man
It's the
about
Planck-
numbers.
It's the Planck time.
I
It's
had
the
to
Planck
draw
time.
out a clock to figure out how
So-
my timesheet at work was adding up.
So let's think about this. You
Okay.
can go back to. Let's just use yours. Minus 32.
I mean, that's like
A 0.32 zeros, and then like a 1.
yeah, it's like
So you
you're
can
pretty much
get
there.
you can get really close to the Big Bang, but in that 0 and 32 zeros, we don't know what happens. We don't understand what happens, and
Because physics is like,
yeah,
I don't work now.
And to be fair, Webb is not going to give us an answer.
No.
So please do not think that Webb is now going to
I
give
took
us an
this in
answer.
a direction that he was not intending it to take. So that's what happens on Cosmos with cosmos.
Yeah. So we are going to need new physics because ultimately quantum physics and general
And
relativity don't
that
talk
is
to
a
each other.
Nobel Prize waiting to happen.
You do that, you get a Nobel Prize. Just go ahead and
Woo.
go ahead and make
Kids,
the trip
get
to
into
Stockholm.
science. You could win $1 million.
Or what kronar or whatever it is that the it's $1 million. It's $1 million.
Okay, I was gonna say. I was like,
What were we talking about? But anyway, so I'm really interested in what happens between that 350,000 years after the Big Bang and this basically 700 million years after the Big Bang. Because
going down, or
there's a
coming
lot
together.
of stuff that's happened. Because if we look at the spectrum that you put up in the picture in the main episode, there are oxygen lines, which means
You had to have stars explode.
you had to have stars explode,
Big
which
stars.
means there are carbon lines, there are iron lines, there are lead lines, there are all gold lines, there are all these different lines.
What is the general time frame for the evolution of life? Not to our point, but like a bacteria on the Earth. That's our only data point, obviously. Like, would there have been enough time in this time for life to come together? Probably not.
As a non-biologist, I really can't answer that question. However, I do believe that I think life on Earth arose within the first billion years on this planet. The Earth is 4.5 billion years old, in which
How long did it take for our planetary not planetary nebula, that's dead stars, our solar nebula to come together and form into our solar system?
Okay, I think for stars to form within a nebula, you're talking millions of years.
Okay.
It is short on the cosmic timeline.
Yes.
And so, but think about this: our sun formed 9 billion years after the Big Bang. Let's just be generous and say 8.5 billion years. There's, as that picture showed of that 13.1 billion year galaxy, you're gonna do it?
I'm gonna go do it, man. Let's.
All right. So as the picture shows, there's a lot of oxygen in it, and I'm harping on the oxygen. There it is, because that's what's in this image. But if the oxygen is there, carbon is there, calcium is there, iron is there. These are all things that we find in our body. Abundance, in abundance. So like with carbon, in our blood, there's a lot of iron. And so if you have oxygen, you have all these other things. So, with no proof, which means this is not science.
We're just talking.
Yeah.
We're just opinionating.
So, with no proof,
we're hypothesizing. We're
okay. No.
hypotheticalizing.
I can say this is a hypothesis, because with the spectrum I see that Webb has given me with oxygen, I could say that, and this is 700 million years after the Big Bang. I could say within 300 million years you have life popping up somewhere. That is a hypothesis.
Okay, I guess my ultimate question, rhetorical question, is then, like, how many civilizations have come and gone? Like, in the length of time that the universe is.
I'm gonna knock that down a notch. I'm gonna say how many planets had life on it that have come and gone. And
how many star systems have come and gone
that did not even arise to the level of a civilization. I think so. What? Drake's equation.
Oh God, yes. Oh my gosh, I used to have this memorized.
So Drake's equation is this equation that will, give you the percentage, basically, of life in the universe. And I think Webb is going to rewrite the Drake equation. It's not going to rewrite the elements. It's going to basically, the Drake equation says,
it's basically like percentage of like stars in a galaxy that are like sun-like or whatever, and then it's like how many of the planets, the amount of using math, the amount of planets that could have liquid water on it, and then the amount of basically at the end of the day, it comes down as the percentage of planets that have life, that have evolved to the point of civilization, of radio signals.
Yeah,
of being able to utilize radio signals.
And the thought is that if you can develop radio signals to go out into the universe, you have at least developed to a point where you have not killed yourself.
Yeah, you are advanced enough to have a semblance of intelligence and evolution that you can then observe. You can basically
so the radio signals go out and we can observe you, and it gives you a percentage, and here's why I really and truly believe there's life in the universe, because that percentage exceedingly small.
Yeah.
But if you multiply that by the number of stars in the universe, we know that it's at least happened once, which means that it probably has happened many more times more. Especially in a universe that's 13.8 billion years old.
Yeah.
And
I like that we immediately took Webb to life in the universe.
But I think ultimately that is one of its scientific objectives it cannot look at a planet and say,
I mean, I guess because they are looking for the signatures of life.
There's a reason why they're looking at the atmosphere. They're not looking at the atmosphere of these planets
for fun, to see what it's made of.
Hey, we're going to count it.
It's kind of like, well, is it made of anything that's similar to what we're made of, and then could harbor something similar to what's going on here?
That's the question. That's why they put oxygen.
Basically, in a nutshell, the reason for our entire exploration of space is a Pink Floyd song, or a quote from a Pink Floyd song. Is there anybody out there?
Yeah, we want...
Can anybody hear me?
Yeah, are we alone?
Yeah.
Are we it? When we look in the mirror, are we it? Or is there an entire universe beyond that mirror that we're unaware of? Is it like we're being interrogated by the police, and when we look in the mirror and we go, okay, this is me, but there's people beyond that looking at us? And to me, the answer is we're not alone. And Webb is going to help us scientifically prove, or at least scientifically say, we're most likely not alone. It's not like Webb can look at this planet and say, okay,
100%.
Hey,
yeah, there's life here.
Hey, there's some methane. There's some methane that is consistent, that is constant, that is replenished. Because when we're talking about methane being in the atmosphere, you're talking about 12 years at most. So 15 years.
Yeah, so you have to have a short cycle.
Yeah. And so and Webb, because of the accuracy that they had in putting it in orbit, is now going to be operational for 20 years.
That's amazing. My mom does ask, does Webb look at the universe in 360 degrees, or do science send it in certain directions? They send it. So they position it. They go, let's move this way.
Yeah. It's in certain directions.
And they also have to, do they move it, or does it move itself so it's never facing the sun?
It never faces the sun, and those heat shields are always facing the sun.
Okay.
Because that's what cools it.
Yes.
Which allows all this beautiful science.
You need to have cool... That's why science is so cool!
Yeah.
Here for our folks.
But also, the Webb
Webb.
My brain melted down for a second.
Mine
Webb
melts.
does not have a large field of view. It's a very small field of view, very tight field of
it's
view.
not a panoramic.
So it's not
telescope.
doing panoramas. It's not doing what in the planetarium
It
biz we
can
call
and
all
all,
skies.
like they can mosaic things together.
Yeah, and so it's going to look at a very specific point in the sky, because scientists are actually astronomers are going to have specific questions to that point in the sky.
Yeah, and you can get better data and resolution if you have more of a focus rather than a broader view. But within that small focus, as we've seen in images such as just looking at Stephen's quintet, is that you're seeing in that small piece so much beyond it.
Mm-hmm,
You know, so it has a small but greater depth of view. It's deep. It's deep.
It's deep.
It's deep.
Your mom asked, there's one out there.
Radio signal ours is out there. I mean, our first radio signal that was strong enough to leave the Earth and fly out into the depths of the universe is the 1936 opening ceremony speech at the Olympics by none other than Adolf Hitler. So our ambassador to space, everybody, to the universe, our humanity ambassador to space is Adolf Hitler. Let that sink in for a moment.
Meanwhile.
And then wonder why advanced forms of life that are more intelligent than us don't come and visit and say hi. And give us their technology so that we can have replicators and then eventually, abolish money and just live peacefully in the universe, but occasionally fighting Klingons and Kardashians. But they're assholes anyway. And eventually maybe we'll come together to fight the Borg, because fuck them. But at the same time, maybe even the Borg we can all join together in one universal federation of love and harmony and peace and existence.
I love you. That was great. Yeah, but that's the only radio signal we know of.
Yeah, but I have a question. With our current technology, have we stopped sending radio signals out into space?
Oh God, no.
Okay.
No.
Because with Netflix and all that, I'm like, we're not
streaming,
utilizing the same.
I get that.
Like aliens aren't getting our current TV shows.
And
I mean, at least they're getting I Love Lucy, and it's a good thing they're not getting The Bachelorette, but.
Yeah, but they're gonna miss out on Ted Lasso. And Orville.
See, that would be like Ted Lasso. That would be a really great ambassador show to space because it's fun, but heartfelt, but
And I'm really looking forward to the next season.
It's the only sports related show we watch.
And you know what sucks is they're not going to be able to see having not seen
our podcast.
Or the Lord of the Rings TV show that's going to come out.
Oh yeah, we're well, they'll know Picard though, but not Picard. But they'll know Picard. They'll know 40-year-old
Picard.
Patrick Stewart.
Yeah. No, yeah. I mean, we're taking. Let's be honest. We're taking a shot in the dark here. We are saying to ourselves there is a project called SETI.
Search for Extraterrestrial Intelligence.
And what they do is they turn the radio telescopes towards the universe, and they look for signals. But we don't know how alien civilizations are broadcasting their content.
That's true.
So the way that TV stations broadcast content is not exactly the same the way that Hitler broadcasted it in 1936.
Right.
And so we're really taking a shot in the dark. We're going to take a look at different frequencies and things like that, and we're going to try to find things that are repeating, but repeating it in such a way that you would not find in nature, like pulsars. Pulsars are very regular in which they repeat.
We need a little aberration.
Yeah.
Something a little funky.
Yeah, something that looks like it's man-made and not.
But also there's the point that that we can only look for what we know, which is like us and what we do.
Right.
There could be existences and technologies that are so foreign from our imaginations, we don't know how to look for them.
Mm-hmm.
So therefore we can only look for what we know, which means that we can miss a lot, or
Right.
there's things that we're seeing that we may be interpreting completely in the wrong way or a different way because we don't know how else to interpret it. So it really is a shot in the dark in that sense that, we honestly, there's so much unknown to us
Mm-hmm.
that we have a very, very narrow field of view of what we know to look for.
Right, and for the longest time, we thought that, carbon-based life was the really only way to go.
Yeah, but they're silicate-based life.
Silicon-based, yeah.
We can't really fathom the possibilities that are out there. And I mean, if but we can take that example just into our own history where, say, early hominids could never fathom where we're at today,
Right.
like in the use of...
Oh, shit, you don't even have to go back to them. Just go back, 150 years ago.
Yeah, I mean, there's
Mm-hmm.
there's a lot that is unfathomable that we can't fathom.
I have watched a lot of Star Trek and Orville and all this stuff where there's like the Jetsons, where there's like flying cars.
Yeah, where the fuck are our flying cars? I don't want to send billionaires into space. I want fucking flying cars. I want the Fifth Element.
Right. So, I have seen all this. And I've seen Star Wars and Star Trek and all this kind of stuff. But, like, we talk about, like, replicators.
Mm.
I've seen it. I've seen it on TV. I still cannot fathom it being in actual existence.
Oh, yeah, because then you're like, oh, God, but...
Yeah, it's
it's
going to be like,
what is the
okay,
engineering of
how? How did you do it?
But the great thing about, I would say, our species, because we don't know great things about other species that's not on Earth. There's plenty of great things about other species, like ants. Ants had made air conditioning for themselves way before humans knew how to do anything. Anyway, I mean, ants are very smart, but in their own, like, survival type of way. They're not making the Mona Lisa or anything, but they're still an intelligent species. But anyway, I'm digressing because alcohol and cosmos. Where was I? I don't know where I fucking was. I got lost on ants.
Meanwhile, you start talking about ants doing like air
and you're
conditioning.
thinking Elden Ring ants?
No. Oh, God.
Anyway.
Damn. No, I was thinking like that dude with the really crazy friggin' hair that talks about aliens.
Aliens.
What was that show?
Ancient
Aliens.
Ancient Aliens.
Ancient Aliens. Such fucking bullshit.
Anyway, where did I start before I started talking about ants? Help me. Where did I start?
We were talking about
Species.
how, like, I was saying, like, I just can't, even though I've seen it on TV, I can't understand, like, in the future if they do replicators.
Yes.
And you were talking...
Yes, I got it. Okay, so a great thing about our species is that we, like, imagine shit and we make shit up and we go, this would be cool to have. But then, like, people look at it and go... I'm going to figure out how to make this work.
Mm-hmm.
And a lot of the times, they fucking do.
Yeah.
So it's like our imagination our creativity and imagination fuels our science and our progress.
Exactly. Science drives science fiction, which drives science, which drives science fiction. It is a beautiful, positive feedback loop.
Exactly. So, it's like you can't say... just because we don't understand it now, like, there could be no replicators or there could be no warp drive, which physics kind of gets in the way. But we can't really say that's not a possibility because we really don't understand everything or do anything at all. Do we understand anything at all? Like,
well, okay.
I mean,
all right. This is gonna sound so weird and cryptic. There's a difference between possibility and possibility.
Oh.
So, science can say some things are possible. Warp drive in science is possible. They've had scientists look at it and say this is possible. But engineers go,
Fuck
is this
you.
possible? And so it's a different definition of possible. Some things are possible and some things...
Now, when you say that, with that example, internally I'm like, well, if the physicists say it, if it can work by the laws of physics, then we just need to figure out how to make it work by the laws of physics.
Right.
Because the laws of physics so far have not lied to us.
No. Here's an example. And this is in the laws of physics, wormholes are possible. In the world of engineering physics, wormholes are not possible. Because what physics says is wormholes are possible. What you need is exotic material to keep that wormhole open.
Oh, exotic. We don't know what it is, but you need it.
So, in terms of physics, what exotic means is these are particles that we don't normally think of, like hydrogen, and so these types of things.
Weird shit.
The shit that we can actually touch and you know, that type of thing.
Yeah, but you're never actually touching anything. But anyway, that's a different.
That is different.
Podcast.
Yes, you don't actually touch anything. 42 exotic material in it. Yes!
Also, Brandon said we spent so long trying to figure out if we can. The engineers never asked if they should.
Yeah, so there's a difference between physics possibilities and engineering possibilities.
But engineering is just like what we can do right now.
Yeah, engineering possibilities, you are limited by the technology of today.
So physics is what we could do, engineering is what we can do.
Right, so physics says, yes, we can do this shit, and then it goes, hey, engineers, figure this shit out because I'm too lazy. I'm going to think about other shit right now.
Yeah.
So,
this is your problem.
We
Experimented it. Now you physically experimented.
Yeah, if you didn't want to figure this shit out, you should have gone in physics and not engineering.
Go draw some pictures, engineers.
Yeah. That's why I changed majors.
I know. That's why I said it.
It's really funny. So, all right, so to give context to that statement...
I'm sorry, I gotta interrupt for Federico. I'm waiting for Improbability Drive at ludicrous speed. Thank you for the 2 imbued references to not Hitchhiker's Guide to the Galaxy and Spaceballs, respectively.
Yeah.
Beautiful.
I originally started as a major in engineering. And
Can you imagine, everybody, if we didn't have Fancy Physics Man today? We had Fancy Engineering Man. It doesn't roll off the tongue quite as well.
No. So, my first semester, I had taken engineering drawing class, and I quickly learned 2 things. I quickly learned that I'd rather study physics, the underlying science of engineering, and also I didn't want to draw pictures. Okay, so fast forward for the whole
Ludicrous speed!
At ludicrous speed. I graduate with a degree in physics, decide I really need to take a year off. That quantum year was tough. I want to take a year off, and
engineering is listening.
And so...
Hey, engineers make the shit,
yeah,
right?
you guys make
do
the
the
shit.
physical work. That's what I'm saying.
To be honest, the engineers are like the creative physicists.
Yeah,
they're the ones that make it work.
The engineers made James Webb. Like, you don't have James Webb without the engineers.
Yeah, the physicists are like, hey,
make this work, and the engineers,
the physicists are like,
they
hey,
make
this
it
is my
fucking
idea.
work.
Physicists are literally like, this is my idea. Take it, run with it, do what you want to do. I'm gonna go over here. I have some coffee.
I'm gonna have a latte.
I'm gonna have a latte. I got my little notebook. I'm gonna write some equations down in Greek letters
that can go in a book.
You do your thing. I'm gonna go over here. So physicists don't really do anything, but I was like, I don't want to draw pictures. So I fast forward to I just wanted to take 1 year off from physics. I was gonna go back into school, but fell in love with the planetarium and fell in love with drawing pictures.
Yes.
So. Making planetarium shows and that type of thing, you have to draw pictures for that. So,
I mean, you don't have to, but it's best practices.
It does
should
help.
Probably storyboard
It does
your shit,
really,
so
really
storyboard
help.
your shit. Anyway, even if it's stick figures, that's okay. I speak from experience because that's all I can draw. I did not get the art bug from my grandfather. Katie got that. Wildixia on Etsy. Wildixia.
Oh, well done. Well done. Well done.
Mm-hmm.
But as the person who looked at those storyboards with stick figures, I knew what you were talking about. And that's all that matters when it comes to storyboards. That's a whole different podcast.
Anyway. Okay.
You're in charge of this.
So we started the main show talking about James Webb's first images, the scientific implications, just the awe and beauty and majesty of it, and what we're looking forward to. The Hangover. We really quickly sidetracked to the possibility of life in the universe as a result of James Webb observations, which...
So it's connected.
So it is connected, yes. And so I just think that shows the possibilities of what we are capable of and the things we have to look forward to with James Webb, which is, a lot of it is due to engineering. Brilliant human engineering to figure out how to get a football-sized telescope into space.
Is it a football size?
It's a football field sized. It's the size of a
Oh,
football field.
with the things.
When it's
with
unfolded,
with the
they
things.
had to figure out how to take gold mirrors and solar panels and fold them up into a little packet to strap onto a rocket that then they blasted off from the surface of the Earth to send 1 million miles away to a certain spot in orbit around the Earth where it stays to then observe the universe and look at shit we can't see with our own eyes or the Hubble Space Telescope. Well, we can see it with Hubble, but just in a different way. It's an apples to oranges.
Yeah,
they're both fruit, but they're
Hubble,
different types of fruit.
And Hubble did have some infrared capabilities.
Okay.
I don't know if it does anymore.
It has a little bit of it, yeah.
But it did.
But
not like this.
Basically, in a nutshell, we are very excited for the future of astronomical exploration with James Webb Space Telescope, the new science that we're going to get, the new understandings of our universe, the things that we're going to learn not only about the universe, but ourselves and our planet and our solar system, because we're a part of the same universe. The physics are the same, and just really kind of the hope and inspiration that this can bring to the world, because there's a lot of shitty shit that is going on, that has been going on, that will be going on, and
this really is a worldwide telescope.
It has taken, we watched the thing and they said there were like 20,000 people that worked on this telescope, and it's not just from the United States. This is it's an international endeavor, and its use is for the entire world.
European Space Agency.
People around the world are going to be using this instrument to expand our knowledge and progress humanity further. So it's really exciting, and there's a lot of people that'll probably just be like, oh, cool, pretty space pictures. But, you know, even if it gets one person looking at one of these pictures when they normally wouldn't, and they stop and they go, oh, that's cool. I mean, that's something. That's then a little spark that's planted in the back of that person's mind.
It's going to be more than one person. And it's going to be more than one person that gets sparked. And this actually, to be honest, this is where, like, Jack and Federico, and speaking of Jack, bye Jack, that they are so important in the story of Webb, is because not only, so yeah, NASA can release these pictures and people are going to see it, but it's people like Jack and Ron Proctor and people in planetariums.
Yeah, the people that take that information and say, hey, community that I'm in, look at this shit. Yeah. Look at this wonder and amazing.
It is.
And we can't really say, like, the kids of today, the future generations that are looking at this go, I want to study that. I want to go to space. Yeah. I want to do this. You know, like, I want to learn more.
How many people so over the years at Dorrance, I was there longer. I had 1 million plus people come through our doors. And so how many of those people that saw my shows, that you saw your shows, or Brandon's, or Catherine's, or Linda's,
or Lena's,
Lena's, anybody's, how many of them were inspired?
Right. I mean, I would have, I had this one autistic boy that would come with his, I don't know if it was his mom or
his
a
dad,
guardian.
right? No, his mom.
No. The dad was there. There was another special needs kid that would come with his dad. His dad would bring him all the time.
No, this is his mom. I remember that.
It was his mom. Yeah, and I won't say his name, but it's weird because I've, like, seen him grow up, and I wonder what he's doing today. But he was autistic, and he would come, and I would let him have an iPad, and he would sit in the back row so he could have his iPad, and he would come to the same he would come to Grand Tour of the Planets all the time, and each time he'd, like, be in a different mood with a different favorite planet, and he would just be so excited and so, like, enthused by it, and he would then, whatever was his favorite planet, he would have, like, all these facts about it, and so it was just like.
And we allowed him to record the show. He was the only one who could record the show.
He was the only one that could, like, record it, and I'd have people come up and say, like when the images from New Horizons and Pluto came out, and I would be in Grand Tour of the Planets, and we'd get to Pluto and be like, hold on, I wouldn't say this, but hold on to your butts, and and I'd bring up the all sky of the New Horizons image of the surface of Pluto in a way we've never seen it before, and I would get audible gasps from just regular people of the public that were just like, oh, wow, that's amazing, so you really, and so it is, I think that this is like the beauty of science communicators, to take that high-level science that you need all your PhDs for and whatever, and break it down to this digestible manner of just like, hey, you don't need that PhD to be interested in this and follow this, and for kids it's like, hey, you can have that PhD, like you can totally be this person that studies this,
they're the true heroes in telling the story of Webb.
It's that story of what the science means and what it can do and what we've learned from it that is really what is inspiring to everybody.
Because, to be honest, so the Webb and the scientists of Webb and the communication offices of Webb, they had their moment this week. That story, that communication is going to continue through planetariums. Planetariums really are the heroes of James Webb, and they're the ones that are going to get that information out there, those images out there, and they're going to inspire people.
So go to your local planetarium, people. If you're in Phoenix, Arizona, go to the Mesa Community College Planetarium.
Okay, well, you could have said, all right. Yeah, so if you're in Phoenix, go to Mesa Community College Planetarium there. If you are in Prescott, Arizona, you can get, there is a planetarium
Embry
there.
Riddle.
Embry-Riddle, yeah.
I don't know if they do public shows.
Here in Salt Lake, you can go to
Clark Planetarium.
the Clark Planetarium.
Or Weber State College.
Weber State.
The Ott Planetarium at
The
Weber
Ott
State
Planetarium
College.
at Weber
Jack's
State.
Planetarium.
Yeah, in
I can never remember
Nebraska.
Planetarium.
And, you know, you can go to whatever town or city that you live in, there's a planetarium, most likely. Visit them, support them, and allow them to tell the story of the universe. And to be honest, in today's world in which planetariums are now built and constructed, to tell the universe to tell the story of science, because these little round rooms with these really weird ceilings, they really tell the story of science, of how the universe works, and it's not just astronomy, it's biology, it's geology.
It's everything.
It's everything. And James Webb is going to give us a little bit of all of that.
Oh my god, I wish I was in a dome so I could put up an all sky of the fucking Carina Nebula or the fucking deep field.
Of the deep field, yeah.
Oh
That'd
my
be amazing.
god.
And then just go, that's the show.
I'd just be like, here it is.
We're going to sit here for 45 minutes.
We're going to sit here and just look at it. Everybody.
And, you know, if you have questions, we'll take them.
Anyway, so check out the James Webb images online. You can follow James Webb Space Telescope on Twitter, and you can subscribe to, you know, newsletters or whatever from James Webb to keep up to date with it. But thanks for joining us on this hangover of Cosmos of Cosmos, where we went in a direction that I didn't ever think we'd. We didn't have a direction. Yeah, but
that's what the hangover does.
That's exactly what we do, because we have alcohol inside of us.
And we're going to go
Which is, thanks alcohol, thank you, Supernovae, for providing us with the method to imbibe alcohol. We appreciate it. Thanks for joining us. Follow us on all the things at Cosmos of Cosmos on pretty much everything, and at Drinking Cosmos on Twitter, only because at Cosmos of Cosmos is too long for a Twitter handle.
All right. Cheers, everybody.
We'll see you around.
We'll see you in 2 weeks.
We'll see you next time with whatever we're going to talk about.
Multiverse, or if Brandon joins us. So we'll see.
Exactly.
Bye.
So, take care. Bye.
Bye. Cheers.